Here, determinant is chosen at random from the set of all determinants of order 2. Order 2 means 2 by 2 matrix whose entries are 0 to 1. So entries are means this place I can fill with 0, 1. Simultaneously, all places can be filled in 2 into 2 into 2. That is 16 ways. That means there are 16 matrices possible whose entries as 0, 1. Among that, the chosen determinant here is set of all matrices whose determinant is not non-zero. Non-zero means determinant can be positive or determinant can be negative. Let us choose elements of yes 1 1 here, that is 1, here 1, that 1, here it is so like this. There are three matrices whose determinant is either positive or negative. So P of E will be 6 by 16, 3 by 8. Here sum of vectors, say this is A bar, this is B bar, this is angle bisector. So vector along angle bisector for 1 unit, it is A bar by mod A bar. We don't know how many units. We will write along this vector is this. How many units are there? We don't know. But it is theta. This one is parallel. Say this is theta, theta. It's angular bisector. This is theta, even this also theta. When two angles are equal, opposite sides are equal. So equation along angle bisector is this. So this he told it as along this sum of the vectors lies, which implies T by mod A bar is 1. From here you can say mod A bar is mod B bar. So now the question here is A bar dot B cap minus B bar dot A cap. B cap means B bar by mod B bar. A cap means A bar by mod A. Since mod B mod A are same, we get 0 is the answer. Here in plus 2 is tan power nx plus tan power n plus 2x dx. 1 plus tan square x is secant square x dx. Tan x is t d. It is t power n plus 1 by n plus 1. That is tan power n plus 1x. So I4 plus I6 will be tan power 5x by 5 plus c. So answer is second option. Here, once function is on to codomain, is range. So range means function values. Tan inverse x plus a must lie between this. Since tan inverse is an increasing function, we write infinite. That means this is the middle one, quadratic expression. So that is x square plus x plus a is positive for all x means domain. Possible when discriminant is like this. If graph happens to be here for some by values will be negative. It is possible when discriminant equal less or equal. That is 1 minus 4a less than 0 or 1 minus 4a equal to 0. That is 1 less than 4a, 4a greater than 1. Answer is first option. Here mod of z square will be zz bar. Based on that, a plus b omega plus c omega square will have a plus b omega, a plus b omega plus c omega square conjugate. A bar is a, then a is real, that everybody knows, like 1 plus 0 I. Conjugate, you take 1 minus here also, 1 here also. So this expression we can write a bar plus b bar omega bar, c bar omega square bar, which can be written as a bar is a, omega bar is omega bar into omega not omega square by, or you can write omega square by omega cube. Omega cube is 1. Similarly, omega square conjugate is 1. Here we can take a plus omega bar is omega square, a square plus b square plus b square, ab into omega square plus omega, bc into omega square plus omega, ca into. So this we can write ab plus bc plus ca omega square plus omega is minus, which is half times a minus b whole square, b minus c whole square plus. Here he told ABC are integers, no two of them are equal. That means we cannot take 1, 1, 2. So the minimum values are 1, 2, 3. Once you substitute there, here, we get half into 1 minus 2 whole square, 2 minus 3, 1 minus 3, 6 by 2. This is not 3. It is square of it. Mod z square is 3. Mod z minimum is root 3. Dy by y minus 1. So integrating log y minus 1 to the base c, fact modulus plus c. So it is log e of x minus 1 minus x square plus, put x as 0, mod f x minus 1 will be f0 minus 1, which is f0 minus 1, since he given that f0 minus 1 is positive. Then it becomes log e fx minus 1 is equal to minus x square plus c. So here, as x approaches infinity, e power minus x square plus c, quadratic equation, roots lie between minus 6 and 1 means what are the possible graphs? Here it is minus 6 and 1, one possible graph. This is not possible because if you take f of x as x square plus 2 times a minus 3x plus 9, f of 0 is 9 positive, but f of 0 is negative. So then let us look at other cases. So between minus 6 and 1, both roots can be negative, right? So in this case, f of 0 is possible. Here, where it attains minima, minus b by 2a lies between. So minus 6 minus b is minus 2 times a minus 3 by 2 lies between that minus of a minus 3 less than 1. So here I will use some space. Minus 6 is less than minus 3. A minus 3 is greater than minus 6. A minus 3 less than 6. A is less than 9. Other possibility, A minus 3 greater than minus 1. A greater than minus 2. Right. So from here I can say A lies between minus 2 and 9. And other possible graph between minus 6 and 1, both roots can be positive. So in this case, minus b by 2a lies between 0 and 1. Here you can take even less than 0 also. It is minus b by 2a is minus 2 times a minus 3 by 2, 0, less than 1. So 0 greater than a minus 3, a is less than 3, or a minus 3 greater than minus 1, a greater than 2 or less than 3. And common condition for all of them, discriminant greater minus 4 times 9 greater, that is a minus 3 whole square greater than 0, a into a minus 6, a less than 0 or a greater than 6. Here I will use some space. So here common conditions for all of them, discriminant greater than 0, f of 0 positive, f of minus 6 positive, f of 1 must be positive. Here these are common condition for both the graphs. So first condition, that is less than 0 and more than 6. F of 0 anyhow positive. F of 1 greater than 0 means what is f of 1? F of 1 will be 1 plus 2a minus 6 plus 9 2a plus 3 plus 1 plus 4 greater than 0, a greater than minus 2. F of 1 positive means a greater than minus 2. F of minus 6 positive means 36 minus 12 times a minus 3 plus 9 greater than 0. 81 minus 12a. 12a is less than 81. 6, 327, a 27 by 4. Right. So for this, f of minus 6 positive means less than 27 by 4. And a greater than minus 2. So in common condition, we have a solution this. But here minus b by 2a lies between different, here minus b by 2a lies between different cases. Let us discuss each one separately. So in this case, I will write 1. In this case, I will write in case 1, minus b by 2a lies between minus 6 and 1. From there, we got a less than 9 and a greater than minus 2. Right. And here even f of 0 is positive. F of 0 means 9 anyhow positive, right? So, and in other case, here minus b by 2a in the second case, less than 1 means we got a greater than 2 and a less than 3. So a greater than 2, a less than 3, and a is more than 6. That has to be here. So this 2 to 3 is not the part of this solution. It is rolled out. So then here possibility is it should be greater than minus 2, less than 9, and less than 27 by 4, and greater than 6. That means the common part is a must lie between 6 and 27 by 4, which implies step of a is 6. This is the only possibility for this equation, right? And here, this one, diameter of the required circle have pair of lines. You take circle for this, so diameters are part of this pair of lines, that is x into x plus 2y. So x plus 3 into x plus 2y is 0, minus 3 minus 3 plus 2y is 0. So y becomes 3 by 2. The center of the circle is minus 3 comma 3 by 2. And he said it is just sufficient to contain. It is containing another circle. This circle whose center is it is x square plus y square minus 8x minus 6y 0 minus 4x minus 3y. Center is 2 comma 3 by 2. Let us say P, CP. So P coordinates 3 comma to come up is asking diameter. First, diameter means CP plus radius of this. The radius is 4 plus 9 by 4 minus 0, 5 by 2. So radius will be CP plus PQ. CP is distance between the points. PQ radius is 5 by 2, 15 by 2. Diameter is 2 times radius, 15 centimeters. Here, alpha, beta are the roots. If you observe carefully this matrix, so it is A transpose is A. Whenever A transpose symmetric matrix, it can be written as product of two determinants. So here 1, 1, 1, 1, 1. I will write so to get 3. Here S1 means alpha plus beta. To get alpha plus beta, I'll write here 1 into 1, 1 plus alpha plus beta, which is S1. S2 here is alpha square plus beta square. Alpha square, beta square. Here 1 plus S1 I will write here. S1 means alpha plus beta required. 1 alpha beta 1 plus. So like that if I write. Now if you carefully observe, if you transpose it, you get other. This is one determinant. So in that matrix, once you transpose one matrix, you get other. So I can say det of A transpose is det A, which I can write it as 1 alpha alpha square 1 beta beta square whole square. So applying row operations, R2 is replaced by R2 minus R1, R3 replaced by R3 minus R2. We get here 0 alpha minus 1 alpha square minus 1 beta square minus 1, which I can write. So alpha minus 1 beta minus 1 alpha square minus 1 whole square. Alpha minus 1 beta minus 1, if you take common, 1 beta plus 1 whole square. Alpha minus beta whole square. So here alpha beta minus alpha alpha plus beta whole square minus 4 alpha beta. So here it is alpha plus beta is minus 1. Alpha beta is also minus. Alpha beta is minus 1. Alpha plus beta 1 square 4 alpha beta is this. So we get 5. That is the numerical. This question 2 cos x plus cos 2 root 2x is 3. It is possible only when both cost function attains maximum values. Here cos 0 2n pi plus 0. Here it is cos 2n pi. 2 root 2x is 2n pi. X is n pi by root. If n is 0, there is a common solution. N is not 0, then 1 becomes 2 pi, other becomes like for n equal to 1. So no common part. So only solution for this. So one solution for this equation. Here it is 100 factorial by 50 factorial, 50 factorial. Power of 7 in 50 factorial is, we have a formula n by p square so on. 50 by 7 square, 50 by 7 cube, so on. When denominator dominates, it is 0, here 49, 8. Power of 7 in 100 factorial is 100 by 7, 100 by 7 square, it is 0, here it is 14, 49, 2 times 60. So here numerator power of 7 is 16, denominator 150 factorial. So finally there won't be any power of 7 after simplification. This one, f is increasing function. It lies between, because f is nothing but a graph x, 2x, 3x. Once it is increasing function, fx is y value here, f of 2x. Now I'm dividing each term with f of x. I'll write here 1 less than f of 2x by f of x less than. So limit extends to infinity. Limit extends to infinity. Limit extends to infinity. So this approaches this problem, good logical problem. So derivative of f inverse x, let g be f inverse. So g circle f of x, because g is f inverse circle f is identity, I of x is x. So g of f of x, once you differentiate, it's 1. G dash fx into derivative of fx is, so which is g dash fx will be, it is dy by dx. So y here is f of x plus e power x. Dy by dx is g dash fx will be 1 by dy by dx. So g dash f of log 2 is 1 by 1 plus e power log 2, which is 1/3. So k here is 1/3. 6k will be 2. Here, let us consider one integral as I1 here is 101 dx. I1 0 to 1, 1 minus x power 50, 101 dx. 1 minus x power 50 integral dx is this. Derivative of this 1 minus x power 50 power 100. Again differentiating, we get dx. Upper limit is 0, lower limit is 0. 0 to 1, 1 minus x power 50 power 100, x power 50 dx. 101 into 50. I'll put 1 minus here. 1 minus x power 50 power 100 minus x power 50. So add and subtract 1 minus 5050. 1 minus x power 50 into 100 dx. 101. This into this. 1 minus x power 50 power 100 dx. This one is 101, which is I1. This is I. So I will be minus 50 I1 plus 5050 I. 5051 I1, 5050 I. So R will be 5050 I by I1. So 5050 I by I1. I1 is 5050 into 5051. Answer is this. Here you write a general term 3 power of 256 minus R. 256 CR 7 power R by 5. R should be multiple of 2 and 5. Only multiple means 2 by 5. You get a irrational terms. R0 is okay. 10, 20. Like that you have how much? 250. So 10 to 250, 25 terms plus 1. Total terms here is 26. So this many integral terms are there.